Right, with this question, we've got the scientist recording velocity of a particle between t equals 0 and t equals 9. Results are shown here on this graph here. So it says use the graph to estimate the acceleration of the particle at t equals 1.5. Okay, remember now it does say an estimate, right? It means you've got to be accurate, but it's hard to get it perfect, and your answer might be different to mine and be different to anybody else's, but you're going to have an answer which is similar, okay, it's very similar. So when you're asked to work out the acceleration from a velocity time graph, okay, you need to draw a tangent, right? It's so important you draw a tangent, and when it says estimate, right, you know it's not going to be spot on, it's not going to be perfect, so you've got to be thinking about doing a tangent. Now it's at t equals 1.5, and 1.5, if you think about it, obviously between 1 and 2, so it's going to be there. That's when you draw your tangent. And be careful when you draw this tangent. You've got to be going in the direction of the curve at that particular point, right? So it's no good me drawing a line like that. Because if I draw a line like that, I'm actually going through the curve. Okay, I need to be going in the direction of the curve at that point. Okay, use a pencil, really important. So I've got sort of the direction of that curve there, right? Push my ruler back a bit. So the important thing is you don't go through it, as I said, you want to just touch it at that point, 1.5 there. So there you go, draw my tangent, okay, at 1.5. Now, what next thing you need to do is to form a triangle. Okay, you need to choose 2 points on this line. Now, one thing which I think is really important, right? I want to point this out. If you're given graph paper like this, where there are no tiny squares, okay, you've just got the squares for each unit, so each number, and here it's going up in halves, isn't it? If you haven't got little squares, it's really important that when you choose 2 points, you choose whole values. Okay, so you know I could choose that point down the line because it goes through the y-axis or the velocity axis at 5 exactly. Okay, so they hold nice numbers, and I'll choose then another value. We'll look along the line here. Now that there seems to be going through that point, doesn't it? So I could choose that point there. Okay, to form my triangle, then joining those 2 points. So I'm going to go across. Okay, and then up. Okay, now going across there, you can see that we call it the step, don't we? We're going across 2.5. Just be careful of the scale here. 2.5, 2.5, and the rise then. Now that looks like there's 3 squares, but let's just check here. Just make sure it is 3, because you're going from 5 to 8. Yeah, so it's 3. Okay, so to get the gradient then, I do the rise, okay, divide by the step. Okay, this gives me the gradient. But of course the gradient in this case is actually called the acceleration, yeah? Right, the acceleration is the gradient in this particular case when you have a velocity time graph. So we work out the gradient, will give us the acceleration. So the rise is 3 and the step is 2.5. So I get my calculator to work that out, and I get 1.2. Okay. In terms of the units, don't forget units for acceleration are meters per second squared. It's very similar to velocity. Look, velocity is meters per second, so you can sort of copy that. You've got to make sure you put a little 2 there, squared. Alright, and you know, when I've marked, I've seen answers that are like that, or 1.4 or 1.5, and I've marked them right, okay, because your tangent might be slightly different to mine. It's just important you get it as accurate as you can, okay, so you go over the slope of that curve, and as I said then, you choose nice points, right? It's so important. It's not ideal if you're choosing points like this one here, okay, it's not very good because you don't know what that is. It's 3 point something, you know, going across, and you know the height would be 8.8 maybe, and it's not so good doing it that way. You're not going to necessarily get it as accurate as possible. Okay, so then part B says use the trapezium rule for and ordinates 0, 3, 6 and 9 to estimate the distance travelled. So trapezium rule, okay, means that we draw trapeziums at those ordinates 0, 3, 6, 9. So we've got we can draw the one at 0. There's no need to draw it because it's 0. So 3, 6 and 9, and again 9, there's nothing to draw there. Okay, now you can form trapeziums. Okay, the most obvious one is here. All right, joining them there. this one then join into here. It hasn't got any length here, so it looks like a triangle, isn't it? Okay, and you've got one here as well. Okay, again, it's like a triangle, but even though it's a triangle, we can think of them as trapeziums. So we call this 1, 2, 3. So area 1, right? The area equals, now the trapezium formula is on page 2 in your exam paper. It's on the formula list. It's there. A and B are your parallel sides. So that side there and this side it goes to 0. This side is 8. So 0 plus 8, and then the height between them is 3. So you times them by 3. Okay, so you work that out. It comes to be 12. Area 2. Okay, again using this formula, so I won't write it down again. Your A, so for this one, your A is going to be 8. Your B is this side here, which is 5, times by the height between them, which is 3. Okay, so you work that out, and it comes to, and you do that on your calculator, it comes to 19.5, and area 3, half. So that side there is 5. This side here is 0 times 3, so you work that out, it comes to 7.5. And it's so important, once you've done all the areas, you need to add them up, right? You need to add them up. Otherwise, if you don't add them up, you won't get the total, which is what we need. And remember, the area represents the distance, so distance is measured in meters, isn't it? Okay, the area and the velocity time graph is given in meters, all right? Gives you the distance rather, and of course it's meters. Now part B, it says, by considering the graph given, state how you would improve on the estimate for the distance the particle travelled during the experiment. And some people have said use different graph paper, which I agree with you. Different graph paper would help you in terms of accuracy with certain things. Okay, but here it says considering the graph given, so you have to go with this graph. Now, one thing I noted here is these trapeziums, they're quite wide, aren't they? The height of them is quite wide. All right. Now, because they're quite wide, they actually, when you look at these here, they don't actually represent the curve brilliantly. Okay, as you can see here, that big length there, there's quite a gap there, isn't it? And especially here, I know there's a lot of things going on here now, but you can see above there, there's an awful lot of things going on. Okay. Because the height of the trapeziums there is quite wide. So what you could do is improve this, to improve the estimate for the distance, is to actually have more trapeziums. Okay, so to make the height of them smaller, so you could have trapeziums at every value. So you could have an ordinate here. Okay, so you could have a trapezium here. Okay, like that. So if you did it like that, you'd have a trapezium. They're not asking you to do that, but can you see you'd have a trapezium there, you'd have a trapezium here. And by having a trapezium here, here, and here, you're actually including then more space. Okay, including more space, which you didn't before. So you're having actually a much more better coverage of the area. Okay, so what we could do is reduce the height of the trapeziums. Okay. Okay, with less gap basically between the ordinates. Okay.